Evening, everyone. So in the last class, we discussed about objects as data and behavior. We also talked about some real world programming examples. And in this class, we'll be talking about the portion 4C and 4D of the syllabus. That is, we'll talk about JVM and we'll see in detail what are compile time and runtime error. Specifically, we'll be talking about the exception class, what are exceptions, how to use them. And we'll first see the what you call the conceptual part, and then we'll see where we can really use exception to make our job easier. So let's begin with the basics. So the first part is basic concept of a Java virtual machine and how it fits in compilation and execution. So let's begin with that. So first we'll move the scribbling software in front. So now what happens in Java is that our source code, that is the Java files which we create, is first compiled into bytecode and then that bytecode is executed. So the idea is that we first create a .java file. Once the Java file is created, that is, this is our source code. This portion is our source code. We compile this source code, and once the compilation is done, we get the bytecode, that is the class file. So the class file is actually the bytecode. And then once we get the bytecode, what we do is this is executed by the JVM. So we execute the bytecode. And finally, we get our output. So this is how things proceed. Now, the idea over here is that unlike other languages, here what happens is that at the lowermost level, we have our hardware. Above the hardware, we have an operating system. And in case of Java, there is something known as a JVM, which sits between your program and the platform. So what happens is that this is how it is. This is our Java program. This Java program actually interacts with the JVM or the Java virtual machine. We are calling it Java virtual machine because for the program, it is just like the hardware. The program interacts with the JVM. JVM interacts with the program. The program does not directly interacts with the underlying operating system or the hardware. And there is one more connected thing. Just first, let me label this. And this portion is actually known as the platform. And when we say that Java is platform independent, it means that they have made a JVM for each platform. Like, for example, if you go to the Java website, you will find that they have JVM for Linux, they have JVM for Mac, they have JVM for Windows, and so on. So since the program is interacting with the JVM and JVM is interacting with the platform, as long as you have a JVM for your platform, it means that your program can run on the platform. That is how JVM achieves the platform independence. Now, so coming back to this, there's a Java program. We compile the Java program, we execute the Java program, and when we are executing this is happening at the JVM level. So in order to compile, the command used is javac. Now I won't be going into the details of this because this we have already discussed 2 classes before, that is in class 0. So you compile the program using javac. You run the program using the command java. And this is what the concept of JVM is. That's one point. So what we have done right now is that we have discussed the conceptual part of the Java virtual machine. Now the second thing is compile time and runtime errors, and then we have to talk about what is an exception, what is an exception class, and the related keywords, that is try, catch, throw, throws, and finally. But let's start with compile time and runtime errors first. So again, I'll move the diagram back. So errors in computer programming can be categorized based on when they occur during the program's life cycle. By life cycle, I am referring to this portion, whether we have written the source code, whether we have compiled it, or whether we are executing it. So the two primary stages of compilation and runtime represent where the errors are coming actually depends on, hold on, what I'm trying to say is, let me rephrase the thing. So there are basically two types of errors. One is compile time errors, that is those errors which occurs during this stage. They are known as compile time errors. And the other is the runtime errors, which occur at this stage when you are trying to execute the program. So if you have errors in the syntax of the language, you are not following the rules of the language, then those errors can be detected when you are compiling them. And there are certain errors which come at runtime. That means you are not violating any rules of the language, but when you try to run the program, you run into an abnormal situation and the program cannot run. So I hope this portion is clear. If there is any doubt, you can leave your query or doubt in the comments, and I'll make sure that I explain that part. Okay, so this is one part. Now let us see how it applies to the programming aspect. So what I'll do is I'll just remove all these things from the front, and then let's make a folder where we can do something. So I'll create a folder and let's call it, I'll just call it errors, because that is what we are dealing with. Then we'll go inside the folder, and today we'll use VS Code for this. Okay. So I'll create a class first, because we have to create a class if we want to run any program. So I'll call it demo.java. And then we'll have a class by the name of demo. Within that demo class, we'll have our main. And then let us do something very simple. So by simple, let's say I want to enter two numbers and display the quotient and the remainder. So let's begin. So what I'll do is I'll say import java.util.asterisk. Then we'll create a scanner class object. Scanner in is equal to new scanner system.in. So this will create a scanner object. The good practice is to close the scanner object towards the end so as to avoid memory leaks. So we'll say in.close towards the end. Now I want the user to enter two numbers, so I'll say system.out.println, or just the print, and we'll display a message. We'll say enter two fractional number. So this will display a message, and let's give them some sensible names. So I'll say float, and that will be followed by the variable. So let's say user will enter a number. The first variable I'll call number, and let's say the user enters the divisor, and I want to calculate the two things, quotient as well as remainder. And then let's enter the number. So number is equal to in dot next float. And then we'll do the same thing for the divisor. So we'll say divisor is equal to in dot next float. And once this is done, we'll say quotient is equal to number divided by whatever the divisor is. And finally, we'll say that, okay, remainder is equal to number modulus divisor. And finally, we'll display the output. We'll say that, okay, we'll say that quotient is, sorry for the disruption, my dog is barking, just hold on for a moment. Okay, anyway, so we'll say that quotient is quotient, and finally towards the end we'll say that okay, remainder is the remainder. Okay, I can notice a query on the chat, and that is why to close the scanner class. So Aman, the reason is here when we say scanner in, we are creating a reference variable by the name of in, and then we are saying that we want to create a new object of the scanner class, and we are passing system.in as a parameter. The main thing is that new will allocate memory for the scanner class, which will acquire certain resources in terms of memory and processes and handles and all. So these resources are occupied, and it's a good practice that once the job is over, we should call the close method to relieve those resources. So it's a good practice and we should do it. Okay, now coming back to this. So right now we have a program which I believe contains no error. Let's confirm that by compiling and running. So if I say run Java, computer will compile and it will run one after the other. So if it's running, it means that there are no compile time errors. So if I run this program, it is asking me to enter two fractional numbers. Suppose I say 5 and 2 and I press enter. So I am getting quotient as 2.5 and remainder as 1.0. That means there are no errors and our program is working. Now, if there are compile time errors, it means that the program is not going to compile. And as I already told you, compile time error means that we are not following the rules of the language. Like say, for example, I missed this semicolon over here. I try to run the program again. Now this will result in a compile time error. The program will not reach the execution stage. See, it is saying syntax error, insert semicolon to complete the statement. Similarly, there can be other things also, like for example, if I misspell something, like instead of new, I say news. Again, if I try to compile, the compiler is going to flag that error also. See, it's not able to understand what I'm trying to do because we have misspelled it. So these kind of things or these kind of errors are known as compile time errors because they are occurring at the time of compilation. Now that's one thing. Compile time errors are detected by the compiler itself, so our job is easier in that case. But let's say the program compiles, like I've removed all the errors now, and we reach a stage where computer cannot proceed normally, and we say that an exceptional situation has occurred. So runtime errors are also known as exceptions. Like say, for example, if I run this program again, there are no errors, the program will run. But I do something due to which the compiler is not able to proceed. Like say, for example, I say one number is 5, other number is 0. Now try to understand, division by 0 is not possible. So if I press enter, computer says, okay, sorry, computer says infinity and the remainder is NaN. This is not an exception. To convert it into an exception, I have to make a small change. Please understand, division by 0 is not allowed in case of integers, and I have taken float variable over here. So very quickly, I'll convert this into int, and I'll convert this and this also into int. I'll remove this and I'll say integer. Okay, now let me run the program once more and then we'll get our exception. So if I run the program again, and this time I say 5 and 0, both are integers. This time there will be no typecasting into float because the variables are themselves integer and we are using next int. So now if I say enter, see what happens. It says exception in thread main java.lang.arithmetic exception division by 0, and then it says add demo.main demo.java :9. Now let us understand this one by one. So one thing is clear, that there is an exception in thread main. That is, we are having an exception within the main method. And then the actual exception class is arithmetic exception, which is defined in java.lang package. Please understand, even if you don't import any package, there is always a package imported implicitly, that is java.lang. So this exception is which is occurring, the class of that exception is defined in java.lang, And then finally, there is a description which says division by 0. That's the description. And then there is something known as a stack trace. We'll go into the details of it in a moment. But right now it says that this exception is occurring in demo.main. Demo is the name of the file. Main is the name of the method. So demo.java is the name of the file. Main is the method. And line number at which this is occurring is line number 9. That is where we are trying to find out the question and perform the division. Okay, that is one thing. Now I can see that Aman has raised 2 questions. One is, what is NaN? We'll be going into the details of NaN in the next class when we'll be discussing data types. But right now, NaN means not a number. We'll go into the details later. I don't want to digress from our main topic. And the next part is, does it have any values? Actually, NaN is a value. Again, we'll go into the details when we reach there. Today, our topic is basically exceptions, or rather compile time errors and runtime errors. So the exception is occurring at this line. That is one thing. Now I said that there is something known as a stack trace, and right now there is only one line which is being displayed in the stack trace, so we cannot understand it very well. So what I'll do is, in order to explain this, I'll just cut everything from here. I'll create one more function and I'll call it public static void, and let's give it a simple name, f. And I'm moving everything inside the function f. And then I'm going to call the function f from the main. Now, the entry point of the program is main. That is, whenever I run the program, the execution will start from the main function. Main function will call the method f. And this time, when we'll enter 0 as the divisor, exception will be thrown from the function f rather than the main method. Let's run it once more, see what happens. So if I run it once more, I say 5 and 0 and I press enter. See, now there are 2 lines, and this is the meaning of the trace. We started from main, so it says at demo.java 9, demo.f line number 9, demo.f line number 9. This is where the exception actually occurred. And then this method, we are not doing any exception handling over here. So once this exception occurred, computer threw an exception. We are not doing anything to catch that exception, or to rather handle that exception. We are not trying to do any exception handling. So computer goes to the calling function, which is main. Here also we are not doing any exception handling, so it is saying add demo.main line number 16. So this is the meaning of the stack trace. Please understand, the idea of a stack is just like a stack of books. You keep one book, then you keep the other book on top of it, then you keep another book on top of it. So basically things are being stacked on top of each other, and the topmost one is the most recent one. So the thing the execution started from main, that is line number 16. Then when it reached line number 9, that exception occurred, and when the exception is finally thrown, it displays the whole stack trace. So that's the idea. If there are any doubts, you may ask now, otherwise I'll proceed. Okay, it seems that the idea is clear to everyone, but anyway, if you have any doubts, you can post it on the chat and I'll follow it through. So this is one part. Now exception is being thrown, and as you can notice, when the exception is being thrown and we are not handling it, computer stops the execution, and whatever the exception is, that is displayed on the screen like it is being displayed over here. Now exception handling means that instead of displaying it on the screen, we want to recover from this problem. We want to do something so that we can take an alternative step in order to remove this problem rather than displaying it on the screen. So let's see how we can do that. So what we can do over here now is that if I put something in a try block, then it's possible that we can react on that exception. So what I'll do now is that the relevant portion, that is from here to here, what I'm going to do, I'll just say remove. I'll put a try block, I'll paste that code back, and then we'll say we want to catch the exception. The exception which is being thrown at this point of time was arithmetic exception. So I'll say arithmetic exception. I'll copy this whole thing to save some time. And then I'll say that, okay, I want to catch the object. So arithmetic exception obj. You can give any name instead of obj. Usually the book says E, so even E will do. E usually means that, okay, object of type exception, so E. And now for the sake of simplicity, I'm not doing anything within the catch block. So notice what happens. I run the program once more. This time when the exception will computer will jump to the catch block, and we are not doing anything inside the catch block. So if I say 5 and 0 again, the program just finishes because the catch block is empty. Let's take it one step further. So now what we'll do is we'll say sout, that is system.out.println, and I'm saying print E. Now please understand, I'm trying to print the object directly. I'm not calling any method. And if you recall, like we discussed in the last class, if you directly try to print the object, any object of any class, computer tries to look for a function by the name of toString, and if the toString method is there, it is called. So arithmetic exception class has a toString method. That means we can print the object. So let's run the program once more and see what is printed if we say system.out.println E. So we'll go over here, we'll run the program, and again we'll enter the same set of values so that the exception occurs. And like you can see, it says java.lang.arithmetic exception division by 0. So when you try to print the message, when you try to print the object E, computer looks for the toString method inside the arithmetic exception class, it finds it, and what it returns is that, okay, this is the exception, that is java.lang.arithmetic exception, and the reason is division by 0. So obviously printing is not a solution, because even when we were not catching it, it was getting printed. But I'm trying to show that the exception object which is thrown contains the data related to the exception. Like say, for example, I can comment out this line and I can say, let's say some other property. I'll say e dot print stack trace. So now what I'm doing, I'm only printing the stack trace. So instead of displaying what it is. So if I run this thing again, see what happens. Computer will display the stack trace. Let it run. And again, I'll enter the same set of incorrect values. And see, this time the stack trace is getting displayed. Similarly, if I want to get just the message, there's a method for that also. I can say system.out.println, and then I say e dot get message. Or for that matter, if I, okay, one by one. So if I'll run it again, this is the boring part. I have to again enter that same set of values, but I'll do it. So 5 and 0. I again press enter and see what happens. It just gives the message, that is division by 0. Similarly, if you are just interested in which class it is, I can simply say e dot get class, and this will give me the class. So if I run it once more and I say 5 0, so it says the name of the class is java.lang.arithmetic exception. Okay, so this is how the basic this is the basic structure of try catch. You give a try block, and then whatever you feel can throw an exception that is given inside the try block. Then you can catch one or more exceptions. Like right now, only one exception is being thrown. Very soon I'll show you how another exception can be thrown. Okay, and then the computer goes to the catch block, and then so we have seen the try keyword, we have seen the catch keyword, and then at the end you can say finally. So finally block is a block which is executed in both the cases, whether an exception is thrown or whether computer goes to the catch block or not. In both the cases, the try block will be, the finally block will be called. So like for example, I'm right now just saying inside finally, see what happens. I'll run the program once more, and this time I will not give a value which will result in an exception. So I'm saying 5-2. I press enter. Remainder is 1, quotient is 2, and computer is going inside the finally block. Let me run the program once more and see the flow. If I run it again and I say 5-0, this time an exception will be thrown. Computer is going to our catch block, and then still it is going to the inside finally block. So any cleanup operation which you want to do, whether or not there was an exception, that will be placed inside finally. Now, one more thing I would like to show you, that let's say I go over here and I say return. I'm returning from that function from within. Okay. So what I'll do is I'll run the program once more. And this time I'm not causing any exception. I'm saying 5-2, I press enter. And notice the interesting part. Even though I'm saying return, before returning, computer is going inside the finally block. And that is what the finally block means. Finally block will always be executed whether or not an exception was thrown in the try block. If an exception is thrown in the try block, it will go to the catch block, then the finally will be executed. If the exception is not thrown and you try to return, even then the finally block will be executed. That's the idea. However, there is one case in which the finally block is not executed, and that is when you call the system.exit method. So if you say system.exit 0, now this is a very bad way of ending a program. Why? Because any cleanup operations like finally block, etc. is not executed. So now if I run the program, the finally block will not be executed even if there is no exception. So if I run it again and I say 5-2, and see, the program ended abruptly once it displayed both the things because it reached the system.exit line. So this is the only case in which the finally block is not executed. Obviously, the other case is you simply close the window. That is more or less the same as what happens when you say system.exit 0. Okay, there is another doubt by Aman, and that is, get message can give us a clarity to trace what errors we have in the program. Yes. So like for example, if you're writing a very complex program and it is not just sufficient which exception was thrown, you can have further if statement inside the catch block to decide how you want to handle it. Okay, so now what we have done, we have seen try, we have seen catch, we have seen finally, and let's see what other methods, other keywords are there. So they want us to know what is try, catch, throw, throws, and finally. So we have seen try, catch, we have seen finally. Now we are left with throw and throws. So now let's discuss about throw first. So throw means that if you want to throw the exception yourself. Right now what is happening is that when we are dividing, the exception is being thrown. If we want to throw the exception ourselves, we'll say throw. Like, let me remove this line first, system.exit. This is no longer required. Let's say I want to throw an exception manually. So what I'll do, I'll go inside the main, and the syntax is you say throw, and then you create an object and you throw the exception. So there are two ways of going about it. One, I can say, let's say I want to throw an exception, arithmetic exception only, without having any actual arithmetic exception. So what I'm doing is I'm saying arithmetic exception obj is equal to new arithmetic exception. So this is, we are creating an object of arithmetic exception first, and then I'm saying throw obj. So now what will happen, as soon as the main will start, now see, computer knows that we are never going to reach this line, so there is unreachable code. So for the time being, I'm going to comment it out. So now our program is very simple. Main starts, we create an object of the exception ourselves, and we throw it. There is no division involved, but we are throwing it. So if we run the program, if you go over here and we run the program, see what happens. Computer behaves as if the exception was actually thrown. So this is the meaning of the keyword throw. Throw can be used to throw an exception programmatically. In the next class, that is in the tomorrow's class, we'll see in detail how we can create our own exception and throw it. Right now, I'm just throwing the inbuilt exception to demonstrate that throw is used to throw an exception. Okay, that takes care of throw, and now we are left with one more keyword in the syllabus, and that is throws. Now, exceptions are of two types. One is a checked exception, one is an unchecked exception. Checked exceptions are those exceptions which must be caught. If there is a possibility of a checked exception and you are not handling it, compiler will complain. Okay? And unchecked exceptions are those exceptions which are not checked by the compiler. If they are thrown, if you want to handle it, you handle it. If you don't want to handle it, you don't handle it. Like in this case, arithmetic exception is an unchecked exception. Now, let us move further. I'll comment this line also. And let's see an example of a checked exception. One very common one is thread.sleep. So if I say thread.sleep, now this is something very interesting. Thread.sleep will just make the computer sleep for given number of milliseconds. Given number of milliseconds means that once the computer reaches that line, it will wait for 200 milliseconds and then it will proceed. So it can be used to slow down something if you want. So now if you can see, there is a red line underneath. If I point to it, it says unhandled exception type interrupted exception. So the thing is that thread.sleep may return the interrupted exception, which is a checked exception. That is, if I don't try to handle it or tell the computer that, okay, I'm okay with it, the program is not going to compile. So see, interrupted exception. So over here, if I go inside this method and I say throws interrupted exception, I'm telling the compiler that, okay, I'm aware that interrupted exception might be thrown by something inside the main method. That is, thread.sleep might throw an interrupted exception. So now see what happens. The program is ready to compile. Now, program is not going to do anything. It will just start, wait for 200 milliseconds and it will finish. But the point over here, which I'm trying to prove, is that there is a possibility of a checked exception being thrown and I don't want to handle it. So I'm saying throws interrupted exception to tell the compiler, or rather to tell the JVM that, okay, I am aware that an interrupted exception might be thrown, but I don't want to handle it. Now, there are other checked exceptions also, like for example, later in class 12, you'll see that if we try to create a new file and let's say there's a possibility that the file cannot be created due to lack of space or due to lack of permissions, then we might need to handle file not found exception. So for that is also a checked exception. So this takes care of all the keywords. We have seen what the purpose of try is. We have seen what is the purpose of catch. We have also seen what is the purpose of throw. And we have also seen what is the purpose of throws. Now, one more thing, let me comment this out also, because I want to show you one more thing. So if I say */ over here, and if I place this line in a try block, then also this error will go away. So let's say I say try this, and then here I say that catch interrupted exception, and I'll say E. And even if I don't do anything, see, the error goes away. So now the computer knows that, okay, thread.sleep may throw a checked exception, but since the user is handling it, though we are not actually handling it, but syntactically, since we have a try block for the computer, we are handling the exception. So now it won't complain. So this takes care of all the keywords mentioned in the syllabus. Let us have a quick recap. Try block is for any block of code which might throw an exception and we want to handle it. In the catch block, we do the actual handling. Throw is used to throw an exception yourself. Throws is used to tell the computer that, or rather to tell the JVM that we are aware that a checked exception might be thrown, but we don't want to handle it. And finally, block is a block which is always executed. Okay, so this is the basic concept of try catch block and how things proceed. So now what I'll do, this was my agenda for this session. In tomorrow's class, we'll go into the detail. We'll just write a whole program where, like, today we just saw the flow. That means what is an exception, how we handle it, but we haven't actually handled it. Inside the handler, we are just saying print something. So what I'll suggest is that you try out these things on your computer, and tomorrow we'll see a real application of try catch, so that you can actually appreciate that what is an exception, how to use it. Now is the time for Q&A. So if you have any questions, you may post it on the chat and I'll answer it. So if there is any doubt, you're not able to understand anything, you want some more clarity on something, please post your question on the chat. Okay, it seems that at this point of time, no one has any issues in what I have explained. So what I can do now is that I'm going to close this session. You try out these things on your own. If there are any doubts, you can leave the message on my Telegram channel. We'll first resolve the issues in the next class, and then we'll proceed with the next concept. And in tomorrow's class, we'll be talking about the actual application of an exception in a program. So that's all for the day. Thank you.